A very warm welcome to Deeksha Vedantu YouTube channel. I hope you all are doing great. And today, since for my 10th class champions, I've got you a very important video of the sample paper for 2025-2026. Now, why is it an important video, ma'am? Sample papers are everywhere because this time the paper pattern has changed. How? Let's see what is the paper pattern. Okay, let me show you the exact sample paper. There is, okay, this is our sample paper for complete science that CBSE has released for 2025-2026. Now if we look carefully, read the instructions, it's saying the total will be 39 questions. There will be total 39 questions, and section A will be biology, section B will be chemistry, and section C will be physics. So earlier what used to happen, we will have a question paper of science completely, and questions were randomly from physics, bio and chemistry, and they were segregated according to their marks. 1 marker question, then in section B 2 marker question, 3 marker question, up to section E, correct? Okay, we know that, right? But what changed is now there will be only 3 sections. Section A will be biology, as you can see the questions. Section B will be chemistry, and then section C will be physics. So let's go to section C and see what kind of paper they have given this time. See, this is chemistry, physics. Okay, so if you see, the first questions are MCQs. Okay, moving on, MCQs and some assertion reason questions you have to answer, kind of MCQs also. Then we have some theory questions based on, it is a mix of now theory and numerical. It's a theoretical question, again theoretical question 2 marker. Then all the questions are compulsory, but CBSE still gives you some internal choices in the question. See, you can either attempt this question or you can attempt this particular circuit. Then another question from human eye, which is 3 marks. Again, a question from electricity, 3 marks. Magnetic effects, 3 marks. Again from light. See, light is a very important chapter, we know. So another question for 4 marks now. Then again we have a choice. See, this whole question you have to attempt, but in part C and D, from part C and D you have to attempt 1 question. So there are internal choices that you are given. Then again attempt C or D. Next question, now this is 5 marks, which is electricity, we know, very important chapter. Moving on. See, now you can attempt either this question A part or this B part. Internal choice is still there, don't worry. Okay, then again internal choice, and our paper is done. Yeah, total 39 questions we have. Now let's go to our PPT so that I can give you complete solution for physics. I'll be solving all the questions of sample paper of physics, correct? Let's start our solutions. Okay, first question says Arnav was making notes. Now read it carefully. It might take you 10 seconds more, but I'm saying again and again, read the questions very carefully and calmly while you are attempting your question, okay? So Arnav was making notes and he wrote down the following statements. What did he write down? From his understanding of reflection from curved surfaces. Now, concave mirrors can produce, what I want you to do, highlight the parts, highlight the keywords. What is this? Concave mirrors can produce both real and virtual images depending upon the position of the object. Now tell me if this is correct or not. With timestamp, comment down in the comment section. I'll give you 5 seconds. Be honest with yourself, be honest with your studies. Answer in the comment section, is this correct or not? Concave mirrors can produce both real and virtual images depending on the position of the object. Now we know this is true because, ma'am, this is my concave mirror and usually it produces real and inverted images. But I know the sixth case. The sixth case says that between pole and focus, if I place my object, then the image will be virtual and erect. So this is correct, that concave mirror can produce both real and virtual images depending on the position of the object. So first is true. Let's see the second one. Convex mirror always produce, convex mirror always produce real and inverted images regardless of the object's position. Now you tell me, what kind of image does a convex mirror produce? A real inverted image or a virtual erect image? Answer in the comment section. Okay, so we know that in convex mirror always produces virtual and erect, not real inverted. It produces, convex mirror produces virtual and erect image. So this option is wrong. Third says, in both concave and convex mirror, the image location can be determined using the mirror formula, where f is the focal length, v is the image distance, u is the object distance. Choose from the following the correct option that lists the correct statement about reflection from curved surface. Now tell me if the third is correct or not. Is this formula correct? 1 by f equals to 1 by v plus 1 by u. This is correct, ma'am. We know this is mirror formula, and we know f is focal length, v is position of image or image distance, u is object distance. So third is also correct. So my correct option will be first and third, that is D option. Correct? Understood? Let's move on to the next question, which says, again an MCQs, choose the correct option from the below which explains the reason for us to perceive the day sky as blue. What do we need to see? Why the day sky looks blue? Okay, let's see the options. First option is, as sunlight passes through the atmosphere, shorter wavelengths such as blue are scattered more than other colors. Like we know, ma'am, of course blue has shorter wavelength than red, and it scatters more because of the frequency. So this is correct. Okay, blue has shorter wavelength, so it has higher frequency, so that's why it scatters more. Now the sky, second option is, the sky appears blue because all colors are scattered equally, but blue light is stronger and more visible to the human eye. We know that all colors does not scatter equally, so this option is wrong. Third option says, the blue color of the sky is due to longer wavelengths like red and orange scattering more than shorter wavelengths, making blue stand out more. But they are saying that the blue color of the sky is due to longer wavelengths like red, but we know blue and red does not have longer wavelengths. Blue has shorter wavelength, so this option is also wrong. D, the atmosphere contains blue colored particles that give the sky its blue experience. Is CBSE trying to fool us? We know atmosphere does not contain any kind of colored particles, so this is also false. The correct option is A. Correct? Next question is, assertion says a point object is placed at a distance of 26 centimeter from a convex mirror. So what mirror it is? It is convex mirror. If a point object is placed, that means u equals to minus 26 centimeter of focal length 26 centimeter. So f is also 26 centimeter. Now the image will not form at infinity. This says that the image will not form at infinity, and the reason it gives is because for above given system the equation, this equation is 1 by f equals to 1 by u plus 1 by v gives v equals to infinity. Now let's look at this question a little carefully. This is my the given is convex mirror. This is my convex mirror, okay, and the focal length is 26 centimeter. Correct? Now if my object is placed at 26 centimeter, if my object is also placed here at 26 centimeter, so it's kind of a focus. Correct? It's kind of a focus because here it's also 26 centimeter, here it's also 26 centimeter. So let's draw our convex mirror first. Let's see what it says. This is my convex mirror and my focal length is on behind the mirror, correct? Now see, the object distances, we have studied two cases in case of convex mirror. Either the object is at infinity or the object is at any point between infinity to pole of the mirror. So this is, let's say 26 centimeter is somewhere here, correct? This is my U. So we know that when the object is placed anywhere between infinity to pole, my image will be formed between pole and focal length. So somewhere here will be my object's image. So it is saying that the image will not form at infinity. That is correct. My image is not forming at infinity. My image is forming between pole and focal length. So A is correct. A is correct. So reason says, for given system, 1 by mirror formula, V will be infinity. But the image distance is not infinity, right? It's somewhere between pole and focal length, so V cannot be infinity. So R is false. R is false. So A is true, R is false, C is our answer. Moving on to the next question that says, the above image shows the formation of an image with an optical instrument. We know this is some kind of optical instrument. Identify the optical instrument in the image. So we need to identify which kind of optical image, which kind of optical instrument this is. Let me write some basic things that I can see in this image. So this is my image, okay? This is the image formed. This is an object. So U equals to minus 20 centimeter, and then my V gives minus 10 centimeter. You guys are aware of the sign conventions, right? If you are not, there are videos on our channel that you can see for sign conventions, for all the formulas, for even one shot rapid revisions and numericals for light chapter, okay? You can go see. Okay, coming back to this, what it is doing, coming parallel, reflecting back, going through optical center. So one thing you need to see, the image, the ray here is not actually reflecting back, sorry, it's getting diverged, okay? It's getting diverged. So in which kind of lens diverges the our light rays? Concave lens or convex lens? Let me know. Which kind of lens diverges the light rays? It's actually concave lens. So this lens will be concave lens. Why it is not a mirror? Because the light rays are actually going through it. And one more thing, if you don't want to see if light ray is going through it or not, it is passing through the optical center and going straight. But in mirror we know there is no optical center. There is just this same thing happens with center of curvature. If my light ray is passing through center of curvature, it will reflect back and follow the same path. But here it is passing that instrument, so it is lens. We know that. Which kind of lens? So it is, since it is diverging my light rays, it is a concave lens. Correct? So first is concave lens. The answer to first question is concave lens. And one more thing you can see, it is making virtual and erect image. Now virtual and erect image is being made by both concave and convex, ma'am, but it is diminished. It is also diminished. So virtual and erect and diminished image is only formed by concave lens. Correct? Let's see the second question, B part. What type of image is formed in this case? We already answered that. It is a virtual, erect and diminished image. Virtual, erect and diminished image. Third point says, based on the measurements given in the image, calculate the focal length of the instrument. So it is just very simple. We know lens formula, right? We will use lens formula here. So 1 by F equals to 1 by V minus 1 by U. My focal length we need to find. My U is minus 20 centimeter. So 1 by minus 20 and my V was minus 10 centimeter. 1 by minus 10 10. So this will be 1 by 20 minus 1 by 10, which will be 20. 1 minus 2, this will be minus 1 by 20. So my focal length will be minus 20 centimeter. And this also proves, I know concave lens, the focal length of concave lens is always negative, and this proves that because through calculation we are also getting negative focal length, which also again proves our answer. Let's go to the next question, which is find out the following in the electrical circuit given in the figure. So this is my figure. First is saying effective resistance of 2 to 8 ohm resistors in the combination. First we need to find the effective resistance of this circuit. Now can I say that these are like this? If I just rotate it a little bit, these are 8 ohm and 8 ohm. So these are in parallel. It's a parallel combination. So the equivalent parallel resistance will be 1 by 8 plus 1 by 8, which will be 2 by 4, 2 by 8, which will be 1 by 4. So my equivalent resistance will be 4 ohm. Correct? So first part is done. Effective resistance of 2 8 ohm resistors in the combination is 4 ohm. Correct? Second part says current flowing through the 4 ohm resistance. This current flowing through 4 ohm resistor. Now tell me one thing. This resistor and this whole part, these are in series. Are they in series? So to find current, we know we have to calculate equivalent resistance first. Let's see how that works. This is 4 ohm. 4 ohm. This was 8 ohm and 8 ohm. Let's just make this for a second. And here is a voltage which was how much? 8 volt. Okay, 8 volt. What we need to do, we need to find current in this circuit. So first I will find equivalent resistance. Now equivalent resistance, because of this we already calculated, was 4 ohm, and both of these are in series. So 4 plus 4 will be 8. 4 plus 4 will be 8 ohm. So this will be my new circuit. Now my dear children, is that correct? And this will be 8 volt. Correct? Now I need to just find current, which I will do with Ohm's law. Current I need to find. I have 8 ohm resistor and I have 8 volt. So from this my current will come out to be 1 ampere. Correct? Now current in the whole circuit is 1 ampere, but just in 4 ohm, ma'am, 4 ohm and the other 4 ohm is in series. So in series we know current does not divide. Okay, so the current from 4 ohm will also be 1 ampere. Correct? Next question, which says study the circuit and find out. The first is the current in 12 ohm resistor. The current in 12 ohm resistor. But don't fool us, CBSE. We know the first thing we need to do to calculate current is to find the equivalent resistance. So this is my, let's remake the circuit. This is 6 volt. And okay, so this is 24 and this is what, 12. So if I need to calculate equivalent resistance of this, these are in parallel. So 1 by 24 plus 1 by 24, which will give me 1 by 12, and equivalent resistance will be 12 ohm for this circuit. So instead of this circuit, can I make this now? This was 12 ohm and 12 ohm. Now we can clearly see that these are in series. So 12 plus 12 will be 24 ohm. So the total resistance in this whole circuit is now 24 ohm. Now I have R as 24 ohm and I have voltage as 6 volt. Can I easily calculate current? I is 6 divided by 24, which is 1 by 4, and I comes out to be 0.25 ampere. Correct? I is 0.25 ampere, but they have asked it 12 ohm resistor. It's same as the previous question. 12 ohm is in what? Is in series. So this will also experience 0.25 ampere current. Now, since these are in series, now the second question, let's say, difference in the readings of emitter A1 and A2. Now tell me one thing, are these A1 and A2 also in series? Correct? A1 and A2 are also in series. So the current between these will not divide. Correct? In series, current does not divide, it remains the same. So A1 and A2 will show same reading of my current. Moving on to the next question, the seventh question, it says you are given 4 resistors, each having resistance of R ohm. Find the maximum and minimum resistance that can be made with these 4 resistors. Done. So what they're saying is that we have 4 resistors, each of resistance R ohm. Correct? Then they are asking the maximum and minimum resistance that can be made with these 4 resistors. Now it's very easy, we know. For maximum, the resistance should be added. That means they should be in series. So we have 4 resistors, R4, all are 4, so 4 into R. So for the maximum resistance will be 4R. For minimum resistance, they should be connected in parallel. So for parallel, that is minimum, this is series. For maximum, they should be connected in series. For minimum, they should be connected in parallel. So for parallel, they will be 1 by R1 plus 1 by R2 plus R4, and it will, just a minute, yeah, for these they will be R divided by 4. Correct? This will be R divided by 4. So for parallel, for minimum it will be R by 4. For maximum it should be connected in series, which will be 4R. Correct? Let's see the second part, which says we have a copper wire of length 2 meter and a cross section of 0.5 meter square. What we are given? We have length of 2 meter. Area of cross section is, what was it? 5.5 meter square. Then we had resistivity 1.7 into 10 raised to power minus 8. Resistivity is 1.7 10 raised to power minus 8. Then what else is given? Calculate the resistance of another wire. Now the wire is another, but it is made up of same material. Calculate the resistance of another wire made up of same material whose length is twice the length of the wire but has the same cross-sectional area. Now there is another wire. This was so we have another wire whose length is twice the length of the previous wire. So 2 into 2, it will be 4 meter. Then area of cross section was same, that is 0.5 meter square. Now since it is made up of same material, the resistivity will be same. The resistivity will be 1.7 10 raised to the minus 8 ohm meter only. And what we need to find? Resistance. Okay, resistance of another wire. So we just need to find, now we know rho equals to R equals to rho L by A, where rho is given 1.7 10 raised to power minus 8, length is 4, and then area of cross section is 0.5. Is that correct? Now you can just solve this and you will get the answer. This will simply be 0.5 and this will be 8. So 6 and 13.6 into 10 raised to power minus 8 ohm will be your answer, will be your resistance. Correct? Done. Let's move on to the next question, which says the above image, this image shows a corrective measure for a particular defect of vision. Correct? There is some defect and it shows the corrective measure. So it's a corrective diagram. First says identify the defect of vision and state what kind of lens is used to correct this deficiency. Now, I need you to see this carefully. What you need to do, it's very simple. You just see what kind of lens are we using. Is it a concave lens or convex lens? So we know this is a convex lens. Correct? This is a convex lens, and convex lens is used to correct which defect? Myopia, hypermetropia or presbyopia? What it is? It is hypermetropia. To correct hypermetropia, we use corrective lens as convex lens. Correct? So I know, identify the defect of vision, it's hypermetropia, and what kind of lens is used to correct this deficiency? That is convex lens. Correct? Also, if you want to see, it was the person couldn't see the object which was this far. Okay? So the person couldn't see the object which was here. This is our object. This is our object. So we used convex lens which converged back the rays to a farther point, because we know in hypermetropia my near point becomes far. It goes away. So this near point went away. Now the person can see clearly. Correct? Now draw and label a ray diagram that shows the defect of vision in the above case before correction. See, read carefully, before correction. So they are asking me to draw the diagram of the same defect but before correction. So for this you should know that in which case, see, if I have some defect, I know myopia and hypermetropia. In one case, the image forms in front of the retina. In another case, it forms behind the retina. So you should know that in hypermetropia, the image is always formed behind the retina. See, this is my near point, this is my eye lens. So these rays go in here, and instead of converging on the retina, they converge behind the retina, and that is why we are not able to see the image clearly. So this is my ray diagram, and you can just label it. This is my convex lens. Okay, convex lens. This is eyeball, and this is my retina, and here the image is formed behind the retina. It's formed behind the retina. Correct? Okay, cool. And this is my near point. This is my near point, or we can say it's our object. Correct? This is a ray diagram which is labeled. Okay, let's move on to the next question, which says a student needs to make a 0.12 ohm resistor. She has some copper wire of 0.80 mm diameter. Resistivity of copper is 0.18 ohm, 10 raised to the power minus 8 ohm meter. Now what we need to find, we need to determine the cross sectional area. Okay, read carefully. We need to determine the cross sectional area of the wire. So first is very easy. Since we are given the diameter, see, the student needs to make this. She has a copper wire of diameter 0.8 mm. So to find the cross section area, I know it's just pi r square, and r will be d by 2. Correct? So pi into d by 2 whole square. So this will be 3.14 into d is 0.8, but it's in mm. We need to convert it into meter. So this will be 10 raised to the power minus 3 divided by 2, and it's a square. So what did we get? A equals to 3.14 into 0.8 into 0.8 into 10 raised to the power minus 6 divided by 4. Divide by 4. Correct? And we can just cancel it. This will be 0.2. So you can just multiply this Yeah, correct. You can just multiply this 6.28 into 0.8 into this was 2, so this will be 0.628, and if you multiply it again you will get 16 and 2 48 5024, and the point will be this and 10 raised to power minus 6. Correct? And you can just shift this point 5.024 into 10 raised to power minus 7 meter square. This will be my area of cross section. First part done. Did you understand the calculation? See, don't just leave your question here. Even when you are practicing, I'm telling, don't just leave your question here till here because I'll solve it later, I'll solve it some other time, concepts are important. No, you can, your marks can be deducted from these calculations if you don't do it correctly. So try to solve these calculations correctly, okay? Revise them, practice them regularly. Now look at the second part. Calculate the length of the wire required for 0.12 ohm resistor. Now I have, see, this is my rho L by A. I need to find length. So I can write resistance into area divided by resistivity. Correct? Now resistance is given 0.12 ohm. So I'll put 0.12 into area. I calculated 5.024, okay, and the resistivity I had was 1.8 into 10 raised to power minus 8. What was it? Minus 8 ohm. Yeah, minus 8 ohm. Correct? Yeah, correct. Okay, now can you solve this? Okay, you can just, if you want to, you can do, if you don't have much time or something, 0.12 into 5, because this is 5.0 and even after that you just have 24, you can simply round off it to 5. Okay, if you don't have much time, you can't do calculation in 5024, just write 5 and 1.8 10 raised to power minus 8 ohm. Okay, correct. The resistance, yes. Now you can just solve it. Okay, can you guys solve it now? Have you practiced? If you haven't practiced it, solve it and tell me the answer in the comment section. Okay, it's whatever time it is now. Okay, the next question says magnetic field lines are shown in the given diagram. A student makes statement that magnetic field at X, this is X and this is Y, magnetic field at X is stronger than Y. Explain this reason if the student claims that it is correct. Okay, now he says that the strength of magnetic field lines is more at X than at Y. Is he correct? Yes or no? Is he correct? Yes, he is correct. Why? Because we know that here magnetic field lines are very close together, and we know if magnetic field lines are very close together, it will be a strong magnetic field. Correct? And if they are far away, it will be a weak magnetic field. So comparing these two, these are far away and these are very close. Correct? So the magnetic field will be more at X than Y. So what did student say? A student makes a statement that magnetic field at X is stronger than Y. So he was correct. Why? Because the strength of magnetic field lines depends upon the closeness of magnetic fields. Correct? Okay. The second, it says also draw the diagram and make the direction of magnetic field lines. So what they are saying, redraw the diagram, north to south. Now me and my kids know, I've told you 100 times, this is the direction of, this will be the shape of my magnetic field lines. Now I know outside the magnet they go from north to south, outside the magnet, south to north, what? Inside the magnet. So north to south outside the magnet, inside they will go from south to north. Correct? We made the diagram again. Okay, next question. Okay, before next question, I want you all guys to click on the link in the description to join our WhatsApp channel. We have been going live for your pre-boards. We will go live. We are going to come up with a crash course for you guys so that you can prepare for your boards completely and crisply, okay, whatever. So go join the link of the WhatsApp channel. You will know everything about the crash course, about the videos that we are putting, about the sample papers. Okay, next question. A big one. Okay, when you see these kind of questions, you need to take a step back and calm down and start reading every word very carefully. Okay, what it says: the above image is that of a digital single lens reflector, DSLR camera. So just say it is a camera now, which are used to take high resolution photographs by professional photographers. Okay, the second image of the above two is a schematic diagram of how an image is formed on the sensor of the camera. So this is my DSLR. This is a representation of how the image is being formed. This is a tree and we can see it's something like this. Okay, and in the image we can see it's inverted. Correct? Clearly visible. The next is, based on your understanding of the lenses, answer the following questions. First is, what type of lens is used in DSLR camera shown in the image? Now, to see what kind of lens that is being used, let us make this diagram into a ray diagram. This is my object and this is some kind of lens I have here. Okay, and my image is being inverted. So out of concave and convex lens, you tell me which kind of lens makes an inverted image and which doesn't. Comment down with the timestamp. Be honest, which kind of lens makes inverted image? That is yes, that is my convex lens, because concave lens always make virtual and erect images, but my convex lens makes real inverted, and in one case it also makes virtual erect, but real is always made, inverted is always made by convex lens. So here I have a convex lens. Correct? So the answer of the first is it's convex lens. Because we can clearly see here that the image is being inverted. Correct? B part is, what type of image is formed on the sensor, and then attempt either COD. Okay, which kind of image is being formed? We already clarified that it's inverted. If it's inverted, then it's real. So the image, where is that? Yeah. So here we can write the image that is formed is real and inverted. Correct? Then coming back to the third part. Now it's a big part. Listen carefully. What it says is, a photographer is using a DSLR camera with a lens of focal length is given. Focal length is 50 mm. To take a close-up photograph of a small object, the lens projects an image into a camera sensor that is located 60 mm behind the lens. Calculate the object distance. So what they are saying is, can I erase this? Okay. So what they are saying is that the lens has focal length of, the lens has focal length of 50 mm. Focal length I have as 50 mm. Correct? And my lens was what? Convex lens. Correct? It was convex lens. So focal length 50 mm, image distance will be 60 mm. V will be 60 mm. Correct? Now we just need to find U. So I can directly use lens formula, 1 by V minus 1 by U. 1 by U can be found out by this formula, minus 1 by F. Okay, now 1 by V is 60 mm minus F is 50 mm. Correct? Now I can just write 300, like take the LCM. 50 minus 60, it will be minus 10 by 300, and it will be minus 1 by 30. Now it is still mm. So this will be 1 by u. So u will be minus 30 mm. Correct? Solved the third part. Okay, let's see the D part, which is a photographer again is using a DSLR camera to take a photo of a flower. A flower is positioned 150 mm away from the convex camera lens. So this is now our object distance. The actual height of the flower is 80 mm. Now they are given height of the flower, actual height, so height of object, and the image height formed on the camera sensor is measured to be 20 mm. Okay, so it's 20 mm. Calculate the focal length of the camera lens. Can I erase this? Okay, I don't have extra. Okay, I'll erase all this. We'll do C part. Okay, D part says, okay, D part says we have u as 150 mm and u is always negative. Then we have the height of object is 80 mm. Height of object is 80 mm. Correct? Then the height of image is 20 mm. But remember, the image now being formed is inverted, so it's below principal axis. So height of image is minus 20 mm. Okay, you need to take care of these very small things. Always remember, highlight the keyword first. Okay, then get the which lens or mirror we are using, then see the focal length and see the signs of it. Okay, remember to see the sign of these focal length, object distance, image distance in your question before starting to solve it. Okay, now my magnification can I find? Okay, they need to find us, calculate the focal length of the camera lens. We need to find the focal length of the camera lens. Correct? For focal length we have u, but we need v. How will we find v now? Because we have this height of image by height of object is magnification. Height of image by height of object is magnification, which will be what? Height of image is 20 mm and object is 80 mm at its minus. So this will be 0.25 minus. Correct? Now another formula of magnification is, can I put m as minus 0.25? Okay, another is v by u and I have u. So this is 0.25 equals to v divided by u is 150. Correct? So if I write v equals to minus 0.25 into 150. Okay, can I calculate it? This will be, I am guessing, 37.5 something. Okay, yeah, yes, it will be something like this, and then there are 2 points. So this will be 37.5 meter, or was it meter or what? Everything was in mm, right? Mm. Okay, so everything was in mm, so this will be mm. So v, the position of image will be 37.5 mm. Correct? Solve the question. Okay. 12th question says, again a big question, but let's see it. Listen it and read it very calmly. Zarina worked as an apprentice, I don't know, in a factory where flashing lights and solar cookers are made. What? Flashlights and solar cookers are being made. She learnt to make the circuits, the design of the light box and light concentrators of the solar cookers as well. She learnt the uses of lenses in making all these tools. Based on your understanding of lenses, answer the following question. Okay. The A part, which they ask us, what kind of lenses are used in flashlight and light concentrator of the solar cooker? Now, to see this, you need to understand two things. What is happening in flashlight? In flashlight, we have a small source and the light is getting away, like it's getting diverged. So we know in my flashlight we will be using diverging lenses. In solar cooker, a lot of light is coming from infinity and parallel towards the lens and it's getting focused at a single point. So I am using a converging lens. So in solar cooker, so diverging lens is what? Diverging lens is concave lens. Diverging lens is my concave lens, and converging lens is my convex lens. Convex lens. So in flashlight I will be using concave lens so that it diverges my light. In solar cooker I will be using a converging lens so it converges my light, which is my convex lens. Correct? You see how you should think, how you should use the right approach to solve these questions, how you go through this question. Okay, next part. Give reason for your choices in your answer for part A and attempt. Okay, we already gave the reason. Okay, this we need for flashlight, we need diverging lens. For solar cooker we need converging lens. Diverging lens is concave lens, converging lens is convex lens. Okay, attempt either C or D. An object is placed 40 centimeter away from a lens which is normally used in a solar cooker lens. See, this is also connected to the first part. If you got the answer wrong to the first part, your whole question will get suffer. Okay, so solar cooker is converging lens, which is my convex lens, and object is placed in 40 centimeters, so minus 40 centimeter is U. The image formed is twice the size of the object, so the image is twice the size of the object. Now let's just write 2 here. Calculate the focal length of the lens. Now see what we are given with. In C we are given that what was given again, forgot. Okay, U is minus 40 centimeter and my magnification is 2, but you need to take care of some things here. It's a convex lens, correct? For convex lens it is always making real and inverted images for first 5 cases, and this in solar cooker the rays are coming from infinity getting focused on focus, so the image is being made that is real and inverted, and for real and inverted magnification is always negative. Correct? For real and inverted magnification is always negative. See, till now you were doing numericals that you have some value, you put it in and you get the answer. Here you have to use your brain a little. Don't just directly put magnification as 2. See which kind of lenses are we using, which kind of image is being formed, and if according to that image my magnification is correct or not. Okay, so my magnification is not 2, it's minus 2. Now they need us to calculate the focal length of the lens. Now we want to calculate the focal length of the lens. For that we need what? V, and V we can find out from here. This is the formula of magnification for a lens, and this is minus 2. U is 40 centimeter, so V will be minus 80 centimeter. Correct? This is also minus, so this will cancel. So V will be 80 centimeter, and to find the focal length we can just use lens formula, minus 1 by U, and V is 1 by 80 centimeter and U is minus 40 centimeter, and you can just add these 80 plus 40. This will be 80, 1 plus 2, this will be 3 by 80, 1 by F. So F will be 80 divided by 3, and you can just solve this, and this will be in centimeter. You can do calculation of this, right? 80 by 3, come on. Okay, D part. An object is placed 20 centimeter in front of a lens which is used in flashlight. Now the case is flashlight. For flashlight we will be using concave lens, correct? Concave lens, because we need the light to diverge outwards, correct? So it's placed 20 centimeter. So in here my U is minus 20 centimeter. Okay, and the image is formed 10 centimeter away from the lens. The image, now in concave lens, image also forms in the same side of the mirror, same side of the object, so it will be also minus 10 centimeter. See, how you have to use your brain. Away from the sun, oh, it's written on the same side. Now calculate the focal length of the lens. See, even if it was given in the question, we still used our brain. That's what you have to do. I just have to calculate the focal length. This will be 1 by V minus 1 by U. It will be minus 1 by 10 minus of minus 20, and this will be minus 1 by 10 plus 1 by 20, which will be minus 2 plus 1, and it will be minus 1 by 20, which is my 1 by F. So F will be minus 20 centimeter. And we know focal length of concave lens is always negative. Hence proved that our answer is correct. And we also rechecked it using the signs and the concave lens and our knowledge on our brain. Okay. Next question says, 13th, says the arrangement of resistors shown in the above figure is connected to a battery. The power dissipation in the 100 ohm resistor. In this 100 ohm resistor, the power dissipation is 81 watt. This has 81 watt power. So calculate the current in the circuit. We need to calculate the current in the whole circuit. To calculate current, we need equivalent resistances first. Correct? Now, what I can do in this case, can I just find from V square by R, can I just find the whole P equals to, okay, let's find the equivalent resistance first. Let's be done with equivalent resistance. If you have any question which includes multiple resistances, first find the equivalent resistance. After that, we'll see what kind of formula we are using. So this is 100 plus these two are parallel. So can I directly write like this? Okay. At this point, we are okay with this, but this is inverse. Okay, I won't. This is 100. So what we'll do, will 1 by 25 plus 1 by 25, that will be 2 by 25, and this is 1 by R equivalent. So R equivalent is 25 divided by 2, which is 12.5 ohm. Correct? So this is 12.5. If I do total, that will be 100 plus 12.5. So that will be 112.5 ohm in the total circuit. Okay? Okay, now we are done with our equivalent resistance. Let's get to the question. The first point is we need to find current. To find current, what we have? We have power, which is 81 watt, and we have voltage, which is given as what? Okay, we don't have voltage, we have resistance here. That is 100 ohm. So for this, I have power now, I have resistance now. I know the formula of power, which includes both current as well as resistor, and I have this 81 watt. I need to find I square, and the resistance is 100 ohm. So can I easily find I from here? 81 divided by 100. If I do the square root of 81 by 100, it will be I. So I will be what? 9 by 10, and it will be 0.9 ampere. So in this circuit, my current is 0.9 ampere. Let's look at the second part, the reading in the voltmeter V2. Now V2 is connected to both of these resistances. Okay? And see, that's why we found equivalent resistance first. So the equivalent resistance of these two is 12.5. Done. And these two, this 100 ohm and this whole, these are in series. So the current will be same in both of these, that is 0.9 ampere. Now I have the resistance. I have resistance as 12.5 ohm, and I have my current as 0.9 ampere. Can I easily use Ohm's law and find voltage? 0.9 into 12.5. Can you easily calculate this and find the voltage? Correct? The voltage from these, the product of current and resistance. Okay. When you find, this will be around, let's calculate this, 45, 18, 22, and this is, I guess, This is 10.25. Okay. Whatever the calculation you can do by yourselves, okay, and you can recheck. Next part is the reading of voltmeter V1. V1, where is V1? Okay, this is V1. Now this V1, the voltage will be the plus of the voltage from 100 ohm and the plus of voltage from this whole circuit. So what I have to do is, I'll find the equivalent resistance, which is what? 112.5 ohm. Again, that is why we calculated this. So I have current now. Current is 0.9 ampere. Equivalent resistance is what? It was 112.5 ohm. Now using again what? Ohm's law, can I easily calculate V equals to IR? Can I easily calculate voltage? Comment down your answers of what the voltage will be, okay? Next question. 14th question says, explain why in household circuits only the fuse is connected in series with all the rest of the appliances. What they are saying? They are saying the fuse is connected in series. Again, read the question carefully. Fuse is connected in series, but all other appliances are connected in parallel to each other. Why is that? So it's a very simple answer, we all know, right? The fuse is connected in series because we want the connection to be cut. If my fuse burns, I want the whole house to stop getting power, to stop getting voltage. And how will that happen? That can only happen in series. And why my appliances are connected in parallel? Why? Because when my appliances are connected in power, each is getting different voltage. So they are functioning on their own. They are getting the current that is required accordingly to their voltage and power they are consuming. Correct? And one more advantage of parallel usage is each appliance can function independently and simultaneously. If my fan breaks out, my fridge won't stop working, right? That is the advantage of parallel combination. And here it's written as well. What is? The fuse is connected in series with all appliances so that it can cut off the entire household circuit, protecting appliances from excess current, thus preventing fires. The second is, all appliances are connected in parallel so that each can get equal supply of voltage from mains. It allows appliances to function independently and simultaneously, drawing the required amount of current accordingly. Correct? Okay, let's see the second part. In a household circuit, an electric heater of power 1500 watt and a fan of power 500 watt. These two are connected in parallel. What? Connected in parallel to a 220 volt supply. 220 volt supply. A fuse rated 10 ampere. A fuse of rating 10 ampere is connected to the circuit to protect it from excessive current. Calculate the total current drawn by the heater and the fan. Now we need to calculate what is the total current that was being drawn by our heater and fan. Now you need to understand one thing. This is a parallel combination, and in parallel combination current is different. Correct? My current is different. So if this is my heater and this is my fan and they are connected in parallel, so they each will be getting different current. What we are given is their individual power, but both of these will be getting same voltage. Correct? Both of these will be getting same voltage. We need to find the total current drawn by the heater and the fan. So I know the formula, that is P equals to V into I. My 220 volt, this is I of heater, and the power I had for heater was 1500 watt. This is 1500. So the current of heater will be 1500 divided by 220. Correct? This is correct. Then the power for fan is given as 500 watt. The power for fan is given as 500 watt. I can use the same formula again. V is same, that is 220 into I of fan, the power is 500. So 500 divided by 220 will be my answer for current of fan as well as current of heater will be 150 divided by 22, and the same goes. Okay. What else they have said? Second question is, okay, the total current will be just the addition of these two, 50 by 22 and 500 divided 150 by 22. You can just add these and get the total answer. Second question is, determine whether the 10 ampere fuse is appropriate for this circuit or if it will blow. Now, I'll just tell you a gist of how to solve it. They have asked the fuses, the rating of fuse is what? 10 ampere. So when will my fuse won't burn out? The fuse won't burn out if the appliances are consuming less current than the fuse limit. Correct? If my appliance is consuming a current between 0 to 9.999 ampere, then it will be fine. Then the fuse will not blow up. But if more than 10 ampere current, more than 10 ampere current will pass through from my fuse, then it will blow up. So tell me in the comment section, will these two, heater and fan, will these blow up? Will these consume more current than fuse limit or not? Okay. Okay. Next question is, okay, an electric heater consists of three smaller heating elements, which is A and B and C, connected as shown in the figure. Each heating element is rated as, okay, all of them are rated as, they have power as 1.2 kilowatt and they have voltage equals to 240 volt. Okay, these are the, all three of them has these same parameters. Then and has constant resistances S1, S2 and S3 are respective switches. The circuit is connected to 240 volt supply. Now what we need to find, calculate the resistance of one heating element. We need to find the resistance of one heating element. So we have P and V. So we know the formula of power, that is V square by R. Correct? V is what? 240 into 240 and this is R, and my power is what? 1.2, but this is in kilowatt. Keep in mind the units, so I'll convert it into watt, and this will be 1200 divided by 240 into 240 equals to 1 by R. Correct? And this will cancel out. This will be, my R will be 448 ohm. Correct? My resistance, these all three resistors are of same resistance. It's given in the question. Each heating element is rated as this and has constant resistance. So all these three elements have same constant resistance, which is what? 48 ohm. Correct? The second question they have asked is, calculate the current in each resistor when only S1 and S3 are closed. See, S1, S2, S3 are switches. Now, see carefully. If S1 is closed, then current will flow through here and it will come back here and everything. Okay. If this S3 is closed, then the current through C will also flow. But my S2 is still open. So through this wire there will be no current. All the current will go from A and in B and in C. Correct? Whatever the arrows, whatever the direction of current is, it will flow only from this wire A and B and C. Through this S2 branch, no current will flow because the circuit is not closed. Correct? So now A, B and C, these are, now okay, let's draw the circuit again. This is A, this is B and this is my C, and this is voltage. This was 240 volt, this is 48 ohm, 48 ohm, 48 ohm. Correct? And we need to calculate the current in each resistor when only S1 and S3 are closed. So let's see. the current through, okay, now this is a parallel combination, correct? And in parallel combination, again we know current divides. So in this branch and this branch, these two branches will experience different values of current, correct? Now I have resistance, I have voltage. Can I find the current using Ohm's law? Let's mark this as 1 and 2. I have to find one current. So it will be 240 volt equals to I1, and resistance is what? 48 plus 48. Resistances add in series. 48 plus 48 will be 96. Correct? So you can find this. Is it correct? Then the current in this second branch, this is my first branch. Correct? This is my first branch and this is the second branch. So in this only has resistance as 48 ohm and the voltage as 240 volt. So my I will be V by R and V will be 240 divided by 48. Done? Okay, I know I1 as well as I2. Now in these the current is different, but through A and B the current will be same since they are in series. Correct? Okay, if you want to solve, I2 will be, I guess, 5 ampere and then I1 will be what? I guess 2.5 ampere. Okay, yeah. So calculate the power dissipated across A when S1, S2, S3 are closed. Now all the switches are closed. S1 is closed, so current is going from A and B. But now S2 is also closed. Now you have to use some brain. What, ma'am? If the current is going through A, and so the current has two options. It can either go from a path which has high resistance, or it can go through a path which has no resistance at all. Okay, this is a path where B has some resistance, that is 2.5. okay, but S2, if this whole branch is closed, this S2 will have zero resistance. Correct? This will have zero resistance. So the current will flow something like this, and the whole resistance A will now become 5 ohm. Correct? Because if you do the calculation, this was 240 divided by 48, but this is now 240 divided by 48 as well, right? The current is not flowing through the other resistance. The current is not flowing through other resistance. So if my current is flowing through this and they are equal in resistances, then my value of current will be 5 ampere, right? Sorry, 5 ampere. Correct? So now the current will not take this path, it will directly go something like this from A and from C. So we need to calculate the power dissipated across A. Now the formula of power is V into I. Correct? The V is 240 volt. Now the I is what? The I is, okay, let me calculate I for you again. For A, since this S2 is closed, this connection, this will not have any current, and this one whole circuit, it has 48 ohm resistance. So my R is what? There is no space. Okay, so my R is 48 ohm and voltage is 240 volt. So if I calculate from here, won't my current will be 5 ampere? Just same like this. That is what I'm trying to tell you. Understood now? Okay. Now my I is 5 ampere. So this is 5. So is it done now? So power is what? 1200 watt. Is it correct? Correct? Okay. Move on to the next question. That is 16th question, my friend. That says two resistors R1 equals to 6 ohm and R2 equals to 12 ohm are connected in parallel to a 24 volt battery. The circuit operates for 5 minutes. What they are given is, we have R1 as 6 ohm, we have R2 as 12 ohm. They are connected in parallel to a battery 24 volt. The circuit operates for 5 minutes. The circuit operates for 5 minutes. Calculate the total heat generated in both resistors. So, we need to calculate the total heat that is generated in both resistors. For heat, can I use the formula I square RT? But for that, I will need I. For I1, we have V by R1. Okay, do we have voltage? Yes, we have voltage. So, V will be 24 and R1 is 6. So, it will be 4 ohm. Correct? I2, that is 1. I2 is 12, sorry. I2 is 12 ohm divided by 6. So, this will be 2 ohm. So, I have I1 as what? As 4 ohm and I2 as 2 ohm. Can I use I square RT? So, H1 will be I1 square R into T. I1 square is 4 square into R is R1, that is 6, time is 5 minutes. Can I solve this? 5 minutes, okay. 30 into 16 and it will be 480 joule. Remember the unit of heat, it's joule, okay. And if I need to calculate H2, that will be I2 square R2 into T. I2 is what? 2 ohm. I2 is 2 ohm, 2 square. R2 is 12 ohm. 12 ohm, sorry, I2 was 2 ampere, not ohm. And T will be 5. Can I solve it again? Into 5, this will be 240 joule. Correct? This is H2. So, calculate the total heat generated in both resistors. In resistor 1, we have 480 joule. In resistor 2, we have 240 joule. Okay. Second says, if each resistor has a power rating of 100 watt. If each resistor has a power rating of 100 watt, then what happens? Determine whether it is safe to use these resistors in the circuit. Determine whether if it is safe to use these resistors in the circuit. For that, we will need the current. We will need the current that is passing through these resistors. We have, that is 4 ohm and 2 ohm. So the total current in my circuit was 4 plus 2, 6 ohm. Okay, and the power is, so the total power will become what? V into I. Okay, V is the total voltage, we know 24. So 24 into 6. So the power is 144 watt in the circuit. Now each resistor has a power of 100 watt and the whole circuit has a power of 144 watt. So it's fine. My resistor is not using more power that is available. Available is 144 watt, but each resistor is using 100 watt. So it's fine. If each resistor is using power 100 watt and I have a reservoir that is giving me power of 144 watt. So it's safe to use resistor in that circuit. Okay, done. And I am thinking that we are done with the physics sample paper. I know the video might be a little long, but I've given you all the solution and we know how important sample papers are for our CBSE exams. So let me know in the comment section if you have any doubts, if you understood any question or not. I'll try to reply to those, and I want you to subscribe the channel first because we are bringing you crash course which you really need for your 10th boards. We are putting so much effort for you guys. So I'll see you in